that said, gang, let's go ahead and get started, man. What are inequalities? So if you already noticed, we have some text in red. All right. So what are inequalities? So let's go ahead and start with equalities. So right over here at the top left, let's go ahead and just start off with equalities or equations, as you guys know them. So with equations, everybody, yes or no, true or false, an equation means that this is the same as that. True or false? Right. I think these are pretty rhetorical questions, but these are important questions to ask because what I'm doing here is I'm setting up the exact knowledge that I'm going to be basically passing off to y'all. So let me go ahead here and give some people the link. I got one more student who needs it, and we are getting started. Yep, you get the link. You get the link. Oprah Winfreying this thing up. Boom, boom, cool. So with that said, yep, equalities, equations mean that this is equal to that. Now, everybody, what does the prefix in? What does the prefix in mean? Help me out. What does the prefix in mean? So if you, for example, oh, that was sufficient versus that is insufficient. Right, it's the opposite. It negates it. You're saying not. And so, long story short, if you weren't quite confident in terms of what an inequality actually is, an inequality is the opposite of an equation. An equation says that this is this. An inequality means this is not that. That's all it means. That's all it means. And there are a few different ways that we can represent this. But right here, it means that the two sides are not equal. Everybody, give me a yes in the chat box if we are good to proceed. And you guys know, when I start off with the basics, you know we're going to be in for a good class. We're going to be able to tackle some pretty tough problems today because I'm here to show you today that there are a lot of simple mistakes that almost everybody makes. But once you get past those small mistakes, it opens up for you. And I'm going to show you exactly how. So with that said, here we go. We got to have a conversation here. We got to look at these examples because if you don't know what they look like and can't practice with the smaller things, of course, the bigger problems are going to confuse us. So taking a look here, we're going to go ahead and look at the symbols, the meanings, and some examples. So if you look over there at the top left, obviously with equals, you see that, 2 plus 2 equals 4. That's a true statement. I think a lot of us can feel confident about that. So with that said, 2 plus 2 is 4. Sure, cool. This always happens. You got to go ahead and close that up. Sorry. All right. So with that said, hey, what's up, Dexter? And so with that said, we're moving into the first inequality that we're going to be looking at here. First one there, we see that it says whatever that means, but that means greater than. All right. If it's pointing to the right, it means greater than. And so here's how we read this. Greater than is the same thing as saying more than. So if we were to read this statement here, 5, that symbol 4, really what that means, everybody, is that we're saying 5 is greater than 4. So give me a yes or no. Give me an honest yes or no. Did you already know this 1,000%? Or were you even less than 1,000% confident? Give me a yes or no. Give me a yes or no. Be honest. And notice, it's okay to say no here. Because again, I'm not the ASVAB. I'm not grading you. I'm an ASVAB coach. I'm here to help you pass it. So you can be as honest as you need to be here. Because again, if you're not honest with where you are and what you need help with, then that's where the trouble starts. So there we are, the greater than symbol. Boom. Here's one way I like to remember it. Everybody, do you notice how like the 5 is kind of pointing at the 4? Yes or no? Do you guys see that? The 5 is kind of pointing at the 4. Yeah. So one way you can think about it is like saying, hey, 5 is bigger than 4. Like, hi, I'm 5. Ha ha, I'm pointing at the smaller number. Obviously, by today's standards, bullying is not okay. But in the sense of math, we can go ahead and use that mentality. We can go ahead and point at the smaller number like, ha ha, I am bigger than you. So in this sense, 5 is bigger than 4. So it's saying I am bigger than you. Now, again, that just means greater than, bigger than, more than, whatever you want to say. But if you flip it the other way around, right here, you have less than. You have less than. And so 4 is less than 10. This right here, with the arrow pointing toward the left side, that means that the smaller number's on the left. 4 is less than 10, which is a true statement. And so what I want to ask real quick, everybody, what I want to ask everybody here real quick is give me a yes or a no as to whether or not what I'm about to write is a true statement. So you can write true or false or yes or no. Either way, doesn't matter to me. But I'm going to write them rapid fire and see how we do. So look over here at the top left or top right. Quick. True or false? True or false? Quick, 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 quick. Rapid fire, rapid fire, rapid fire. Quick, true or false? So we have some mixed answers here. And again, like this is why it's so important to really work things out like this. So let's just take a closer look. We have 10, and that symbol is pointing to the left. And so remember, the bigger number points at the smaller number. And so if we have 10 less than 12, is that true? Is 10 less than 12? It is. This is a true statement. This is a true statement. What about this one over here? What if we said, is that a true or false statement? That is a true statement as well, because 7 pointing at 5 saying, hi, I'm bigger than you. That is true. Absolutely true. Let's go and try another one now. Maybe this one will be true as well. True or false? Yeah, it's going to be false. Absolutely going to be false, because if you're saying 2 is greater than 5, no, that is not correct. 2 is smaller than 5. 2 is less than 5. So false. Here, I'll go ahead and write true and true. So moving up next here, let's go ahead and try 2 more out, and then I'll go ahead and move forward here. Let's go ahead and say we have true or false? What should it actually say? What should it? It should say equal. Yeah, that's right. That should say equal. 100 is not bigger than itself. No number is bigger than itself. Every number is itself. So 100 cannot be greater than 100. 100 is 100. Let's go ahead and try another one out here. Let's go ahead and see last one, or maybe 1 or 2 more. So let me just write false here. Let's try 2 more here real quick. All right, coming up, we got, let's go ahead and say, quick, true or false, true or false, true or false, quick, come on. Rapid fire, come on, come on, come on. All right, cool. So let's go ahead and read it out. Again, let's read this out and let's see if it makes sense. 17, everybody, is that greater than, less than, what is that? What is that? Yeah, that's less than. So 17 less than 15. Is 17 less than 15? No, absolutely not, right? 17 is bigger or larger or greater than 15. And so therefore, not going to work. False too. So that was just a short little exercise in terms of just understanding how this works. But it doesn't stop here. Has anyone here, remembered that inequalities can come with a little extra business going on, kind of like not just less than or greater than, but symbols like this. Who here hates those? Yeah, so we're going to be going over those as well. So don't worry, this is a full service class. We're going to be going over all of this starting now. So sometimes you're going to see that symbol where there's a little underline underneath the greater than or less than. So everybody, what does that underline mean? What does that underline mean? Yeah, it's basically saying that this is going to be greater than or equal to, or the other way, less than or equal to. And so we're gonna go and actually explore this a little more deeply than the other ones, because this is one that a lot of people get confused with as well. So here we are. The symbol over here, if it's pointing to the right, like it's greater than, but it's also underlined, all that means is you're saying greater than, so over here, greater than or equal to. So it's kind of like taking the equal sign, taking one of those lines out, because you're trying to fit the greater than with it. Now, let's go ahead and make sure that we understand this. Let's make sure. Everyone, is the statement true only if both is greater than and equal to, or is it one or the other to make it true? Which one is it? And again, give me your honest opinion. I got like 10 people so far. We got 91 people here. Come on now. Go ahead. Come on. Give your opinion. Give your opinion. There ain't no judgment here. So I see a lot of people saying both. And again, I am here to address a lot of these misconceptions, because again, at the end of the day, it's these small little mistakes that we make that add up to that test anxiety, blanking out on word problems, memorizing formulas but having no idea how to use them. Am I sounding like anybody here? I'm not going to judge, but what we need to make sure we do is commit to understanding these small little mistakes, because we don't want to end up failing, obviously. So here we go. Here we go. Greater than or equal to is what it means. So if we go over here, let me just go ahead and walk you through what this kind of looks like. The top left, I'm using a letter because you might see that today. You obviously will. But the other three, this is where a lot of you are going to actually be like, okay, this makes sense. So the first one, if it doesn't make too much sense, that's fine. But this first one is basically saying, hey, whatever A is, it's going to be at least 5. It can be 5, and it could be greater than 5. Either one is fine. But A is greater than or equal to 5. What that means is whatever A is needs to be 5 or above. Because if you think about it, what if A was 6? Is 6 greater than or equal to 5? Yes or no? Right, it is. And which one specifically? Is it the greater or equal? Which one is it? Right, it's going to be the greater, right? It's the greater part of it. Remember, it is one or the other, either one. If either one of those conditions is checked off, then you're good. That is a true statement. So if you're looking over here, everybody, is this a true statement? 5 is greater than or equal to 5. Is that a true statement? It is. It actually is a true statement. Here's why. Although 5 is not greater than 5, 5 is equal to 5. Remember, having that underline gives you both. It's saying, hey, it's either greater than or it's equal to. Whichever one is true, we're good. If they're both false, then the whole thing's wrong. But if one of those is good, then we're all good. And that's why if you have 3 is greater than or equal to 3, that still works, because 3 is equal to 3. So this part of things makes it true. Everybody, yes or no? Are we feeling a little more confident about what this crazy symbol means? Any more confident there? Cool. Sounds good. So we're going to go ahead and actually take a look now at the less than or equal to. Then we've got practice city. All right. So the next one here, less than or equal to. Remember, whenever you have that 2-part symbol here, less than, and then an underline, greater than with the underline, that means it's either going to be less than or equal to it, greater than or equal to it. And or means either one, not both, either. There's a difference. There is a difference. So checking out these examples, if we were to go ahead and say, hey, B is less than or equal to 12, that basically means B is at most 12. And let me just explain really what that means. This again means B is at most at most 12. Because if you go any bigger than 12, guess what happens? It's going to be false. Watch this. If I even went a little above 12, if I even went to 12.1 is less than or equal to 12. Everybody, is that true or false? That red statement right there. Right, false. It is false, it is false, it is false. Because 12.1 is not less than 12. It's not equal to 12. And so therefore, both of those are wrong. So the whole thing's wrong. So that's what that means. Less than or equal to means at most. Greater than or equal to means at least. And so we'll get into more of that later on, especially when we start doing word problems. Because yes or no, everybody, have you seen a word problem that asks you to find the maximum amount of something that you can do or the least amount of something that you can do? Yeah, those are inequalities. Those are inequalities. So by coming here today and being able to solve these inequalities, you'll be able to handle those word problems a little better because you can identify those key words. Remember, I don't just say things and put things on the screen just to put them there. Everything has a purpose. Think of it like a Marvel movie where every single little detail is going to come back in the future. All right. So let's go ahead and talk about solving inequalities, because this is where a lot of us may be, again, a little apprehensive, a little anxious, and that's okay. But we are here to break things down into as few steps as possible. So solving inequalities, I'm going to tell you right now, it is, with a small group of exceptions, solving inequalities is basically like solving equations. One more time. You solve an inequality the same way that you would solve an equation. There are a few minor differences, but first allow me to remind you how we actually solve equations. So please go ahead and take a screenshot. Take a screenshot of this. You guys know that the one thing I love doing is making sure that you're listening to what I'm saying and not trying to rush and copy things down. So if you need to, go ahead, take a screenshot of this. We'll refer back to this as time goes on. But as a reminder, the way we solve equations and inequalities, step one, make sure that you simplify both sides if you even need to. So you know that sometimes with equations, you don't need to do anything. Like sometimes it's just, just subtract here and you're done. But there are times where maybe there's two variables on the same side, combining like terms, or there's a 5 and a 2 here, bring them together for a 7. So if you notice that you need to simplify, please make sure to go ahead and simplify. That's the responsible thing to do. Now, number two is going to be basically moving everything that has a letter to one side, everything that has just a number to the other. Basically, what you're doing is you're starting to isolate the variables. So we'll go over a couple of examples. Please don't feel nervous yet, all right? But again, move all the terms with variables on one side, solo numbers to the other. And as a reminder, if you needed to just kind of remember what it sounds like, just opposite operations. That's all you're doing. If you want to move a 5 to the other side, subtract 5 from both sides. If you want to get rid of a minus 2x, add 2x. Opposite operations. All right. Then next, once you do that, you'll get the variable by itself. And don't worry, we're going to go over examples. I got you. But we're going to get the variable by itself again. Opposite operations. If you see a number being multiplied to it, divide. If you see a number being divided, multiply. It is straightforward, just like that. And again, plenty of examples to come. Plenty of examples. Then lastly, checking our work. Everybody, let me ask you this. How often do you check your work? On a scale of 1 to 10, with a 1 being I never check my work, I always just look at the answer key. I don't ever plug things back in. To 10 being I literally check every single problem I've ever done. There should be no 10s here. There should be no 10s because I know you're lying. But I want to know where we fall under that. A 1 being I never check my work. A 10 being I have checked every single problem since I was born, which there should be no 10s here. Okay, so again, take a look at this honest survey result here. A lot of us don't check our work. And the thing is, to build confidence at first, how are you supposed to feel good about what you're doing if you don't know that you know how to do it. Not that you don't know that you got it right, because we can all check the answer key and be like, yeah, we got it right. Woo. But that's not the point. The point is not getting it right or wrong. Everybody, I'm going to give the mic to everybody right now. Everybody, it's not about getting the problem right or wrong. It's about what again?
Understanding the why.
Understand why.
Understanding the process and why.
Understanding the process and why.
So, with that said, my party.
Understanding the process and why.
Ooh,
Understanding the process and why.
Absolutely. Appreciate you guys. And I just cut the mic off again. But those are some of my students that are in my program. It is not about getting a problem right or wrong. We can get lucky. We can have a bad day. That happens. But it's ultimately going to come down to, do you know why? That's where true confidence comes in. If you don't have that confidence, then I can understand why you have test anxiety. I can understand why you blank out on word problems, because you haven't been in that situation before in your head. You got to know the why. So without further ado, what we're going to do now is we're going to proceed here, and we're going to start talking about, again, the example of how equations and inequalities are pretty much the same thing. There are a few key differences that I'm going to go over up next over here. So don't worry, but this is how they're very similar. Notice that we have the same equations. One's an equation, one's an inequality. But everybody, how is it that I'm going to get from this step to this step? What am I going to do first, everybody? What is the first step? Right, the first step will be simplify, but there's nothing to really simplify here. So the next step is really going to be, hey, let's get those numbers by themselves on one side. Let's get the variables, the letters, on the other. So if you take a look, everybody, notice how over here for the equation, we have the variable here, but notice how we have a number here and a number there. I want to get these numbers together. I want to get these numbers together. And so remember, whenever you want to move anything to one side or the other, you're going to perform the opposite. Oh, the opposite what? Everybody, what is it? Opposite what? Type it in. Opposite operation. Opposite operation. It's not going to be opposite sign. It's going to be opposite operation. Be very careful about how you say that, because once we start getting into multiplication and division, if you have negatives involved, that's where things might get tricky for you. So focus on this. Opposite operation, not sign, operation. So what we're going to do here is subtract 1. Everybody, is that the only thing I have to do? Or am I missing something? What am I missing? Thank you, Lizzie. Thank you, Marquette. Both sides. That's right. I love the participation today. There we go. Yes. Whatever you do to one side, remember that you do to the other. That's how equations stay balanced. And so, boom, we subtract 1. Everybody, what's going to happen right here? What's going to happen right there? Cancels out. Exactly. If you add 1 and subtract 1, you cancel out. You end up right where you started at 0. So boom, that's going to be gone. That is going to cancel out. And then 7 minus 1, that's going to give us 6. There we are. That's going to be right there. So the next question is, how do we get from 2x equals 6 to the answer? How do we do that, everybody? Be specific. Be specific. Don't just say divide. Don't just say 2. Don't just say this. Bring it all together. Bring it all together. Demaya, there we go. Demaya is the first one. I believe Demaya is the first one. Oh, no, Peggy was the first one, but Demaya, shout out as well. We need to make sure we're being specific about our actions here. So to get x by itself, we are going to divide 2 on both sides. Not divide, not 2, divide by 2 on both sides. And so with that, I know I sound like a broken record. I know I do. But at the end of the day, if you pass, I'm losing my voice. I don't care. Cool. So here we have it. If you're multiplying by 2 and you divide by 2, that's where that red cancellation comes in. Because remember, everybody, between the 2 and the x, we don't see any specific operation symbol there, right? But if 2 things are attached without a symbol, what can you always assume, everybody? So if you have 2 and an X together, or 2 parentheses right next to each other with no symbol at all, that is always going to be multiplication. That is always multiplication. So this right here, currently what's happening is multiplication. That's what's currently happening. And so the opposite operation is division. Yes or no, everybody? Do we see that? Because we see multiplication here, the opposite operation is division. Yes or no, do we see that? Thank you, my party people. Thank y'all. So there it is. We divide by 2 on both sides. And so the 2 is going to cancel out, like I just said. And everybody, 6 divided by 2 gives us 3. Correcto mundo. So you may be asking, well, hey, Anderson, thanks for the recap on equations, but I didn't come here for that, my guy. I came here for solving inequalities. How are your inequalities different? Well, let's find out. So we're going to do the same things here. We're going to do the same exact thing here. The first step, what did we say we were going to do? Be specific. Don't just try to be quick. Be specific in the chat box. What is our first step? And be very specific here. I'm going to train y'all today. Subtract 1 on both sides. Felicia, first one there. Thank you. Appreciate that. And a lot more people are going to get that right as we continue going along. Demaya, subtract from both sides. Christine, subtract from both sides. Subtract that 1. Thank you. Subtract 1 from both sides. -1 on both sides. Thank you, guys. Appreciate that. So, yep. First step, nice and easy. So far, there's nothing different. This right here, it's going to cancel out, leaving us with just the 2x. And then it looks like I made a small mistake here in making this. Allow me to go ahead and fix myself real quick. Right over here, just a quick fix. Boom. Thanks for understanding that. And so, yeah, thanks, Jose. And so there we are. We have 2x is less than 6. And now from here, we're going to do the same thing. Do the opposite operation. Because we see a multiplication here, we're going to do the opposite and divide. And divide. That's right. We're going to divide both sides by 2. Pedro, I got you. No worries. I got you. So we're going to divide both sides by 2, which is going to allow us to receive cancellation. And 6 divided by 2. Can't even highlight it because of the white, but 6 divided by 2 is 3. So everybody, in this specific problem, was there any difference, besides my typo, was there any difference between solving the equation versus the inequality? Was there any difference at all? Not at all, right? Not at all. And so these are the kind of problems that kind of bait people into believing that inequalities are very, very, very simple. They're not. They're a little more complicated than equations, just a little more complicated. And so I'm going to show you what those key differences are now. That way, when we do see those situations, we're good. Okay? Got to make sure we understand this. And so, yes, Christine, the responsible thing to do would be to plug things in. So here is a main difference, Christine. Here's the main difference and the beginning of it between equations and inequalities. The answer was 3. So what we're going to do here is plug in 3. Let's take the first one here. Let's take the equation. Let me switch this up. Cool. So the answer was x equals 3. We had 2x plus 1 equals 7. So everyone, because x is 3, that x, I'm going to replace it with 3. So we're going to have 2 multiplied by 3 plus 1 equals 7. Everybody help me out. 2 times 3 is what? Correct. 6 plus 1. Everybody, is 6 plus 1 7? Yeah, it is. Cool, we're good. And everybody, does 7 equal 7? Right, 7 does equal 7. We're good. We're set. This is a true statement. We're good. But let's go ahead and turn our attention over here. The question here is, okay, this says X is less than 3. Everybody, will it be a true statement if we plug in 3? We're on it right now. That's right. It's going to be no. It's going to be no. Because if you plug in 3, first of all, if you plug in 3, 3 is not less than 3. False. That is false. If you were to plug in 3, you're going to get 7 is less than 7, which is not true. So everybody, what is this telling you to plug in? X is less than 3. What is it saying that you can plug in? You could plug in 2. You could plug in 1. What other numbers could you plug in? 0. Absolutely. What else can you plug in? -3, -1, -1. You can plug in 1.1, 1.7, 2.3. You can plug in anything on earth that is less than 3. Anything at all in the world that is less than 3. Don't believe me? Watch this. I'm going to go ahead and plug in 2. Let me plug in 2. So if I plug in 2, let's see what happens. Let's see what happens. 2 multiplied by 2 plus 1 less than 7. Okay, so help me out, everybody. 2 times 2, hit me. Easiest question of the day, right? Yep, that's going to be 4 plus 1. That's going to be less than 7. Everybody, what's 4 plus 1? Help me. 5, that's right. And so is 5 less than 7? Absolutely. So again, the reason that we couldn't plug in 3 for the inequality was because it wouldn't make the statement true. It wouldn't, because you would have gotten 7 is less than 7, which isn't true. The answer we got was, hey, X has to be smaller than 3. If we plug in 3, it's wrong. We plug in any number less than 3 and we're fine. Any number less than 3 and we are fine. And there we have it, my party people. So with that said, let me go ahead and answer Maya's question and we are moving forward from there. What's up, Maya?
Okay, I get everything. I've been getting the whole process, but we got X is less than 3.
Yeah.
And how is that not the answer?
So again, that is the answer. The answer is X has to be less than 3. If you plug in 3, that's not less than 3. That is 3. You want less than
okay. X is just a blank variable. So
exactly. It's just a placeholder.
you can just put any number in, but it has to be less than 3.
You can plug in 1, you can plug in 0, you can plug in negative 525,600 minutes, whatever it is, you're good. You're absolutely good. Absolutely. And so with that said, my party people, let's talk about these exceptions that we really need to make sure we go through here. These exceptions here are 2 things. 1, whenever you multiply or divide by a negative number, you will flip the inequality symbol. So basically a shortcut, everybody. If you want to change everything's sign, you can just flip the symbol. So let's go ahead and backtrack to that one problem that I told you from the beginning. Hey, this might prove to be a little rough for some people. So here's an example. One example is, let's go ahead and say this purple here. Let's say we have negative X equals, or excuse me, negative X is greater than 5. Let's talk about that real quick. So everybody, there's a negative symbol in front of the X. And what do we always say? If there isn't a number in front of the letter, if there isn't a number in front of the variable, what number is always there? Yeah, it's always gonna be 1. It's always gonna be 1. And so if you wanted to, I'm gonna zoom in for a second. I'm gonna zoom out, don't worry. I'm gonna zoom in for a moment here. If I wanted to solve this, like the standard, like mathematically correct, like grammatically correct way, the mathematically correct way is gonna be understanding that there's a 1 in front of this. And everybody, What's going on between the -1 and the x? What operation is that? Right, multiplication. That's what's happening there. So to solve this, we need to do the opposite and divide by the -1 on both sides. But here's the thing, everybody. Whenever you multiply or divide by a negative, true or false, anytime that you multiply or divide by a negative, you change the sign of the number. True or false? It's true. Yeah. Whenever you multiply by a negative, you always change the sign. +5 times -1 is -5. -20 times -1, +20. It switches. It switches. Multiplying by a negative switches the sign. And it also switches the inequality. Gotta make sure we know that. Switching the sign also switches the inequality. And so when we do this here, we're going to end up with, a negative and a negative. That's going to make the positive x. And then the 5 becomes a -5 because everybody, 5 divided by 1 is still 5. But when you divide by a negative or multiply by a negative, change the sign. That's going to be a positive or a -5. And then this right here, it has to switch. So I'm going to use alternate colors here to make sure you see that. Got to make sure you do that. Got to make sure you do that. All right. And so I see what you're saying. Misunderstood the question. Hey, no worries. No worries. And so memorize that rule to begin with, everybody. Memorize that rule. If you wanted to keep the things nice and simple, I got you here. Let me just give you another example. If you want to keep things super easy for yourself, just know that if you have, let's go ahead and say a -x less than or equal to 10, literally do this. Switch the signs, switch the inequalities. So I'm going to make this +x, -10. That's going to swap and you're done. If you're going to switch the signs, switch the inequality symbol. Write that down. If you're going to switch the sign, you're going to switch the inequality symbol right here. Right there. All right. Write that down right there. You can change all the signs and flip the symbol. All right. So I'm going to present a few more examples here. That way we don't flip out when we do see this. Okay. So again, like this, both of these things are the same thing, really. Both of these things are really the same thing. But if you're going to multiply or divide by a negative, just switch the symbol with it. So another example. And I want you guys to contribute here. I want you guys to contribute. If we had, let's go ahead and say -x is greater than or equal to -17. Let's go. Actually, let me take away because you guys don't have that symbol in your keyboards. So we'll just do greater than. So we have -x is greater than -17. What is the complete answer going to be? X, this or that, what? What is the complete answer going to be? Give it a shot, everybody. Give it a shot. Christine, X is less than 17. Above Christine was Janice, less than 17. You shorthanded it. You should have put an X there, but I'll still accept that. X is less than 17. X is less than 17. That's right. So what you're going to do, again, if you want to get rid of a negative, just change everything's sign and flip the symbol. That is it. That's all we have to worry about here. This is one of the few key moments where I'll say it's okay to memorize. I'll give it to you here. I'm going to say it's okay to memorize here. Okay. I'm going to make a little 10, 15-minute video and put it on YouTube in terms of why that actually makes sense. All right. But for the sake of being able to tackle as many problems as possible, I'm going to go ahead and forego that and just give you the memorization step here. But I will make a video explaining why that all works. So it'll just be X, swap it, 17. Change all the symbols, change all the signs. That's it. That is it. And so, Lou, you had something to add on to this? Again, Maya, write that down there. You can change all the signs and flip the symbol. that's really what I want you to write down. We will be going over plenty of examples there. So Lou, I'll go ahead and let you add on to that. Let me go and find you here. Go ahead, brother.
So what I want to add to that, so when I took my test, a lot of these problems, they were actually flipped backwards. And a lot of the signs they used, they use different signage and everything else. They make, so it's the same problem, but they word it differently to throw you off.
Hey, I appreciate that. We're actually gonna be going over those problems as well. Right now, we got to make sure that we go through these basics. But yeah, they can absolutely flip it. We've got plenty of those problems here today to work with. Appreciate that, man. And so with that, over here, Maya, if you still have a question, let me know. If you still have your hand up for a question. But we're going to practice this. And I'm going to show you exactly how to get this done. All right, cool. Go ahead, Maya.
I'm not getting this process. Change the sign and flip the symbol.
Gotcha.
I feel like I knew it before, but I forgot.
No worries. So Maya, all we need to know here, is when you multiply or divide by a negative. So write that down here.
I wrote it down.
Perfect. So all we need to memorize here, because again, I am leaving out the explanation because it is a little bit of an explanation. That's why I get why you're confused. But for right now, all you need to memorize is whenever you multiply or divide by a negative, that's that inequality symbol, the one in the middle. It needs to flip. It needs to flip.
Okay. So that's if I'm multiplying or dividing with negatives at the end, just flip the sign.
Absolutely. That's it. That's it.
I made it more complicated.
Hey, you're good. You're good. That's it. So I gave you a little shortcut here. If you want to change all the signs, change the symbol. That's one way to think about it. But literally the rule is whenever you multiply or divide by a negative, flip the symbol. That's it. That is it. And so Jose, was that the same question? I gave you the mic there if you want to go.
No, I have another question, Coach. Will you still treat it the same? You know how you got like negative X and then with greater than 10? Whatever. I mean, say if it's the other way, say the negative 10, do you still do it? Do you still treat it the same way? Say if X was positive but 10 was negative, will you still treat it the same, like flip the sign, but instead of 10 being negative now, X would be negative?
So that wouldn't be necessary because typically what you want to do is you want to solve for the variable, the letter. And so if the X is already positive and by itself, you're done. No other work to be done. You're good.
So you wouldn't flip the sign even if the 10 was negative?
No, you wouldn't. You're fine. You want to get the X by itself as positive. And so that's why you look at all these examples. We start with a negative, negative, negative. If it was already positive, like X is greater than 2, you're fine. Nothing to do there. You're good.
Okay, I just want to be sure.
Yeah, we're going to work with plenty of examples. I got you. And so, and what I meant here is if you swap the sides, you must flip the symbol. So there are going to be times where you'll receive an answer like this, everybody. There will be a time where you receive an answer like this. 2 is less than X. So what this rule means over here, if you swap the sides right over here. So if you swap the sides, you must flip the symbol. And so that's right there. So the rule is if you want to have the X on the left side or the Y or the M or whatever letter you're using, doesn't matter. If you want it to be on the left side, not the right side, all you need to do is swap them and flip the symbol. So this over here turns into this over here. X and 2, but instead of less than, it's going to be greater than. Because if you read it, think about it like this, everybody. The X is pointing at the 2. So it's basically saying, hey, the X is saying, I'm bigger than you. I'm bigger than 2. And so that's exactly what it's saying. X is greater than 2. So if you flip the numbers or swap the sides, flip the symbol. This is going to prove to be very useful when we get into these example problems coming up. But with that said, here's what we've got going on, everybody. Again, we just took like 10 minutes on this because it's way too important. You multiply or divide by a negative, flip the symbol. If you are swapping the sides, flip the symbol. Those are the two major rules. Very easy to overlook, but very major rules. So what we're going to do next is we're going to be taking turns here. We're going to be working together on the first page, then the page following, you're going to work alone. The maximum time that I'm going to give you is 1:30 per question, and that's going to be for those harder questions at the end. In the beginning, the one-step problems, you're going to get 30 seconds per question, and the goal is really to answer as many as you can, confidently too. If you only get one out of the 3 or 4, that's fine. If you only get 2 or none, hey, again, the important thing here is that we grow. So allow me to go ahead and start us off here. And so what we're going to do here is we're actually going to go ahead and ignore these graphing points. I was debating doing them today, but right now I really just want us to be able to solve these. So with that said, we are simply going to go ahead and work on solving these and make sure we have enough space there. Cool. So let's work together on these. Let me scroll down so nobody has that recording symbol in the way. So, hey, no worries, Christine. Hey. Remember, we're going to learn how to do these. These are actually super straightforward. I promise you. So let's take a look at number 1 over there at the top left corner. We got V divided by 3 is less than or equal to -4. So everybody, Karen, no worries. I got you. So let's take a look here. The first problem, I'm going to highlight it. Let's highlight it. So everybody, quick question. With the V, what operation is currently happening to it? What is currently happening to the V? Right, currently division is happening to that V over there, right? It's V over 3, V divided by 3. So everybody, what is the opposite of dividing by 3? What is the opposite? Multiplying by what? Don't get lazy. Yeah, by 3, exactly. Multiplying by 3. So with that said, everybody, is this problem as hard as we are making it look? Really not. It's really not. It is really not. All we have to do here is opposite operations. We have V divided by 3 is less than or equal to -4. All we need to do here is do the opposite operation. We see a division of 3. And so what we will do is do the opposite and multiply both sides by 3. So with that said, everybody, when I multiply and divide by a 3, what's going to happen with these 3's? What's going to happen? They're going to cancel out. Exactly. It's the same thing as taking 2 steps forward, 2 steps back. They negate each other. Multiplying by 3, dividing by 3 cancels itself out. So that's going to give us, a little bit of a reprieve here to say, hey, this is actually not terribly crazy hard. So with that said, booyah, we have V. Now, everybody, pop quiz time. Are we flipping the symbol here? Did we multiply or divide by a negative? Like, did we do that to both sides? Did we multiply or divide a negative on both sides? Both sides. No, we did not. Notice that was a 3. That is just a 3, not a -3. We did not multiply or divide both sides by a negative, and so the symbol stays the same. Everyone, exactly, Maya, only if you do it to both sides. Only if you do it to both sides. And so everybody, a -4 times a +3 gives us a what? -12. That is correct. Because a negative multiplied by a positive is still going to be negative. That's fine. And 4 times 3 is 12. So one-step problem, that's what the majority of these are going to be in the beginning. Then we're going to get it into 2-step problems for sure. But there we have it. Next, let's take a look at number 2 here. Again, I'm here to show you that this is not as bad as you might think. So let me go ahead and there we go. So number 2, all the way up there, we have -8r is greater than -88. Okay, Karina, it's all practice. Again, it's all practice. I got you. So negative 8r is greater than negative 88. Everybody, what operation is currently happening between the negative 8 and the r? Yes, multiplication. That is currently what's happening. Janice, to answer your question, everybody, Janice's question was, so only when you multiply or divide a negative number on both sides do we change the inequality sign. Correct. Only when you're doing it to both sides simultaneously. And when you're the one doing it, not if it's just like presently there, when you're the one doing it. Yeah, correct. So here, what's currently happening is multiplication between negative 8 and r. So everybody, what's the opposite of multiplying by negative 8? Hit me. Be specific. Remember, we're doing the opposite operation, not opposite sign. Opposite operation. The operation currently is multiplication. The opposite is division. You will divide the same number. And so, because we are dividing both sides by a negative 8, what do we have to do with big old buddy over here? What do we do with buddy? Yeah, our sign has to flip. The sign right there has to flip because he looks at this and is saying, oh, both sides are going to be negative. I'm going to flip too because I'm getting mad now. Whatever you want to think about it. I don't know. However you want to characterize it to help yourself out, do it. But that is going to change to less than and then just solve as normal. So over here, the negatives and the 8s cancel out, leaving us with just r. Everybody, a negative divided by a negative is a what? Yeah, positive. A negative divided by a negative is a positive. 88 divided by 8, my party people, is, hit me, 11, correct. So really, look, this is just like solving an equation. The only difference that might give us a lot of headaches, the only difference though, is, hey, when we're dividing or multiplying both sides by a negative, this thing right here, that symbol needs to flip. That's it. Exactly. So Janice, I'm going to make that video for us to make sure that we truly understand why we flip it. Because again, I hate being that kind of teacher that tells you to memorize something without truly understanding it. But I did also know that with this class today, the more time we have to practice, the better. And I would have taken about 15, 20 minutes to explain that. So yeah, but here we are. Here's another problem, everybody. We're here. P divided by 3 is less than or equal to, again, less than or equal to 20. Everybody, what operation is currently happening to the P? What operation is currently happening? Yep, a division by 3. So everyone, the opposite operation, division by 3, opposite operation would be multiply by 3 where? Alex, go ahead, give me the full sentence. Don't come back like you forgot it. Go ahead and hit me with the whole thing. Multiply by 3 on both sides. We have to be specific here. We do not want to risk forgetting what to do when the pressure comes in. So here, multiply by 3 on both sides. And so everybody, this is going to be correct, right? We're going to go ahead and cancel out the 3, obviously. And then we're going to have P greater than or equal to 60. Correct or incorrect, everybody? Yeah, correct? No. False. What y'all talk about, man? Somebody want to raise their hand and tell me what's wrong? Anybody want to raise their hand and tell me what's wrong? What's going on, Maya? What's wrong, Maya?
You didn't multiply or divide a negative number on both sides.
Oh, so I shouldn't be doing that, right? I shouldn't be flipping it. Is that what you're saying?
Yes.
Okay. Hey, London, confirmation here? Do you agree or disagree?
She's right.
Okay. Mikhail?
It ain't Taco Tuesday, so no shenanigans, sir.
That's why I love having you, man. So yeah, no. I did not multiply or divide by a negative, and therefore I should not have flipped the symbol. And so because of that, we need to go ahead and do our due diligence here. Obviously, I knew that was going to happen. That's the one thing I wanted to avoid there because I had the number line that I erased. But let me go ahead and just do my job here. And so the symbol stays the same. The symbol stays the same. I flipped it just to mess around to see who's paying attention, and I couldn't get it past y'all. Y'all were on top of things, and I appreciate that. And so with that said, let's turn our attention over to number 4, and let's go ahead and have ourselves a ball here. So 18n is less than or equal to 324. Everybody, before we even begin, ask yourselves, are we gonna have to flip the symbol? In this problem, are we gonna have to flip the symbol? Okay, give me a reason why. I see a lot of no's. Why? Why? Be specific. Why? Why are we not going to? Kayla, hit me.
Because we're not dividing by a negative.
We're not divided by a negative, and we're not also...
And we're not multiplying by a negative.
Exactly. Kayla, beautiful. So with that said, again, everybody, I hope this is starting to make sense here. That is the only rule. Whenever you multiply or divide by a negative, you flip the inequality symbol. That's it. And so all we're doing here, dividing both sides by 18 to get the n by itself. And so this is where things get fun, because you're sitting here like, yay, let's go ahead and do 18 divided into 324. That sounds like fun. Let's go ahead and do it. So let's go ahead here. 18 into 324. All right, everybody, how many times is 18 going to 32? Just once, right? Just once, just one time. Because 18 times 1 is 18. 18 times 2, 36. 36 is too much. Only once. Only once. So we subtract 18. Everybody, 32 minus 18 is what? 32 minus 18 is what? Who knows? Ooh, Karina, quick. There it is. But almost. Alex is correct. 14. 14. Close to the 24. Close. One way you can do it is you can subtract 10, then subtract 8, because that is 18. But there we are. That's 14. And then we will bring down the 4, making it 144. This is where we look at it like, oh, crap. How many times does 18 go into 144? How many times is that? Alex, you want to take a guess at 8? It's not 12. We're going to take a guess at 8. Hey, let's try 8. Let's try 8. Let's try 8. If we used 8, 18 times 8, let's try it out. 8 times 8, 64. 1 times 8 is 8, plus 6, 14. Okay, so 8 will work. And so I will do a class and show you how this can be a lot faster. But long story short, the answer will be 18 in this problem. So n is less than or equal to 18, which is weird, but cool. So here, so you could split it up, Marquette. Again, that's one of the mental math techniques that I'm not going to go over today. But if you are in my program, know that I do have a split and glue strategy for division. There's actually 2 strategies. One is estimation and compensation, which I haven't taught recently too much. But one thing I also do is splitting and gluing. All that means, everybody listen up. If you're trying to divide by 18, everybody really quick, is 18 9 times 2? Yeah, right? If we're dividing by 18, that's the same thing as dividing by 9 and then dividing by 2. So you don't have to divide by 18. You can divide by 9, do the math, then divide by 2, do the math. That is a lot easier to divide with 1-digit numbers than what the hell, right? So I just want to make sure you know that. But again, I'm not going to get too much into it. Not going to get too much into it. I'm going to go ahead and move forward here to make sure that we have more practice time. So we've got 6 questions here. And what I'm going to do is I'm going to give you guys 30 seconds for each of these questions. So We have 6 questions times 30 seconds. That's going to be 3 minutes. So I'm going to go ahead and set the timer here, starting now. So let's go ahead and get through it here. Let's go ahead and try these out. And again, they're going to get harder. Don't worry, Roger. Don't worry, Roger. They are going to get harder. So here in the first one, all we saw in the beginning here was, again, you want to focus on what you need to do to get the letter by itself. So I got B right here, but right now it's being divided by 14. So what you need to do is go ahead and do the opposite of that and multiply by 14. And that's exactly what was done here. It's exactly what we did. And did anybody notice that when you multiply both sides by 14, oh, wait, there was a 14 here that cancels out and a 14 there that automatically cancels out. Did anybody do that? Or did anybody multiply the 11 with 14 and then divide by 14? Which way did you go? Which way did you go? Did you cancel out automatically or did you multiply then divide? The first way, canceled. Cool. Yeah. So I hope that you noticed that for sure. Sweet. And so, yep, we will be canceling that out. Exactly. And that's why that happened right there, to give us B is greater than or equal to negative 11. Notice the symbol did not change because we did not multiply or divide both sides by a negative. Number 6 over here. We see that P is being divided by 4. We have to do the opposite of dividing by 4. So that's why we multiply by 4 on both sides. And that's what gave us 20 times 4 being 80. On the left, canceled out. I'm going to zoom out a little bit so you can see both of those answers while we keep going. 3x is less than or equal to negative 57. What we have here is, it's just a 3 with the x. We have to divide both sides by that 3 to get the x by itself. And so we have a negative 57. Again, even though it's a negative, we are not dividing by a negative. That's what's most important, okay? Has anybody here made the mistake between 5, 6, and 7 of accidentally flipping the symbol? And again, be honest. Has anybody here made the accidental mistake of flipping a symbol when they shouldn't have? Okay, so if you did, do you now understand why you should not have flipped the symbol? Do you understand now, though? Does it make more sense now? Again, it's only when you're dividing or multiplying both sides. So basically, if you're dividing or multiplying a negative to get the x by itself, that's when you flip. If you need to get the x by itself by multiplying or dividing by a negative, that's when you do it. But again, here, dividing by 3 gives you negative 19. You keep it the same way. Next, wait, Chimney, I got you after this one. I got you. So Chimney, I got you right after this one here. So we have the m, and it's being divided by 14. Everybody, what do we need to do to both sides? Multiply or divide? Multiply, correct. And we're going to multiply by 14. So let me grab blue. So we'll multiply by 14. And let me actually, I hate that those numbers are so close. So allow me to just do it over here. Okay, so here, all we're going to do, multiply both sides by 14. Bye-bye right there. And we'll get m is less than. And so, did anybody here notice that what you can do is, instead of canceling anything out, anybody here know that 14 is the same thing as 7 times 2? Like, isn't 14 the same thing as 7 times 2? Like, why would I do 14 times 3, which I know a lot of us did. And we got 42. Then we divided by 7 and we got 6. I know a lot of us got that. But let me give you a little shortcut way here. Good, guys. 14 is the same thing. So, or times 7 times 2. And let me actually put this above so you can still see it. So, or it's the same thing as times 7 times 2. Does anybody here agree? Anybody here agree that I can replace the 14 with 7 times 2? We are perfectly able to do that. Because again, 14 is 7 times 2. But the reason I did that was because, guess what? I'm going to give myself a much, much easier time because the 7 and the 7 cancel out, leaving me with just 3 times 2. Everybody, 3 times 2 is 6. It's going to be 6. That is one way you could have done it. Again, one way you could have done it. Instead of looking at it as 14, you can look at it as 7 times 2. The 7s cancel. You're just left with the 2 to multiply. But again, let's go ahead and assume you went ahead and did it straightforward. You could have done it and still got the same answer. Watch this. So m over 14 less than 3 over 7. We multiply both sides by 14, blah, blah, blah. Cancels out. Watch this. Everybody, 14 times 3. Let me just go prove a point here. 14 times 3. Here we go. 4 times 3, that's going to give us 12. Carry the 1. 1 times 3 is 3. Carry the 1 is 4. So we have 42. So what this ends up becoming ends up being this. M is less than 42 divided by 7. Everyone, 42 divided by 7 is gonna be what? Six. Exactly. It's gonna be 6. And so M would be less than 6. So everyone, do we see how, again, it's just a small little thing with messing around with numbers. But do we see how if we kind of work to understand how to deal with these little like quirks about math, these little nuances that we can learn, we can save ourselves a lot of time with those nuances. Are you guys seeing that? Yes or no? Are we seeing that? Oh, no, we wouldn't have multiplied, Jose. No, we wouldn't have multiplied there. We wouldn't have. We would not have. And so I would love to get some input here from Chimene. Chimene, what's your question? I got you. Thanks for being patient. Oh, I think you muted yourself. I'm going to go ahead and give you the mic again. Go ahead. Chimene, I think you keep muting yourself accidentally. I'm going to give you one more chance there. Let's see if that works.
Can you hear me?
There we go. Perfect.
Yeah, I just want to know when to divide or to multiply.
Yeah, so great question. What we want to do again is think about the opposite operation. So Chimene, follow along here. Right here, do you notice how it says m divided by 14, right?
Yes.
Cool. So what we will do is we will do the opposite. Instead of dividing by 14, to get the answer, we need to do the opposite, which is multiply by 14. So every single time, what you're going to do is you will do the opposite operation. Notice how here we see it's 3 times x. And what we'll do is divide by that 3 to get it by itself. So it's all about performing the opposite operation each and every time here, each and every time. So we got to make sure we understand that there. So I hope that makes a little sense. I do need to move forward to Peggy here. So Peggy, go ahead. But I want to make sure I get to Peggy and Jay before we move forward.
Okay, coach. For the number 8, I don't want to go to M. That is what we just solved. Instead of doing the 7 times 2 up, I just canceled. I just did it like 7 goes into SL1 and then goes into the 14, 2, and then I multiply the 3 by 2 to get a 6.
That's exactly what I did. Yep, you got it down. Yeah, you have it down. That's the exact same thing that I did. You just worded it differently, but you're doing the exact same thing. You understand it for sure. Good stuff. And then lastly there, Jay, what's going on?
Okay, so you only flip the symbol when there's negatives on both sides, right?
Yeah, when we're doing it to both sides. Yeah, when we are dividing or multiplying by a negative on both sides. So you're going to see that here with number 9 over here. So Jay, watch this. Notice how we have a -4 in front of the x. And so notice, Jay, yes or no? This is multiplication. It's -4 times x right now, right?
Right.
Cool. So we're going to do the opposite operation and divide by that -4. So this is a perfect example of how the symbol will now flip. Because notice how we are again dividing by a negative on both sides. Does that make a little more sense now?
Yeah, that makes sense. Thank you.
Booyah. I got you. No worries. So with that said, booyah, my party people. Here in this one, the negatives are going to cancel. 4s are going to cancel. And we're going to have x. What's going to happen with that symbol, everybody? Is this correct? Yeah, we got to flip it. 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 So this symbol, let me actually go ahead and use black there. This symbol flips to a negative. And then 56 divided by a negative 4. Everybody, before we even do the math, a positive divided by a negative is a what? Negative. A positive divided by a negative is a negative. It is a negative. It is a negative. And so here what we'll do, 4 dividing into 56. And so with that said, 4 going into 56, 4 goes into 5 one time. Bring down that 6. 4 goes into 16 4 times. And so the answer there will be negative 14. So anybody here feeling a little better about handling those negatives? Are we feeling a little better? Gotcha. Cool. I'm glad. Jose, what's up, boss? I got you, man. Let me go ahead and find your unmute button right there. There we go. Go ahead, Jose.
Why a negative 14? I just flipped the sign, but I didn't got negative 14.
Yeah, so 56 divided by 4 is 14, and a positive divided by a negative. So whenever they're opposite signs and you're multiplying or dividing, opposite signs always ends up with a negative. Same signs always ends up with positive. And so, Jose, I want to hit me up at your class because I want to direct you to that negative numbers tutorial that I did, that I put on YouTube. I want to direct you to that one because that's the biggest key there to really building confidence with negatives.
Okay.
All right. So I know you know how to do division of 56 divided by 4, but it's those negatives that can definitely trip us up. I understand. And so here, v divided by 3 is greater than negative 9. So if we're taking care of this here, everybody, what will we do to both sides to solve this problem? Right, multiply by 3 on both sides, correct. And so we will go ahead and get that done. And so we will multiply by 3, multiply by 3. So the correct answer is going to end up being, let me go ahead and correct myself there. The correct answer, everybody, confirm it for me. V is less than negative 27. Is that correct? No, exactly. It is not correct. It is not correct. It is not correct. I flipped the symbol when I should not have. I did that on purpose, obviously, but it should not be done in this case. So what I'll do is I'll go ahead and correct myself. Keep it as greater than negative 27. We did not do that. Christopher, absolutely. We're going to get into that in a moment. I got you. So I'm going to go ahead and zoom on out for y'all. There it is. Please go ahead and take a screenshot here if you'd like to take a screenshot here. But what we're going to do now is we're going to proceed into adding and subtracting now. The following ones that you're going to see below have it where it's flipped on the other side. But we're also going to go over, again, we got to get to the adding and subtracting and then bringing it all together, okay? So with that said, this right here, we're going to move forward now. And we're going to get into adding and subtracting. So right over here. So let's go ahead now and explore the other operations. Before I continue though, Zoom user, I'll go ahead and give you that mic right there. Oh, if you want to go ahead and put your hand back up, I got you. I just don't know which Zoom user you are. Oh, actually, I see you right there. Go ahead, boss.
I mean, we just passed the subject. I mean, it's fine. I was gonna ask the first two questions, the examples. What was the difference? I was gonna ask about it, like, because one of them you multiplied and one of them you divided, and why? Like, what was? I mean, I understand that one. The first, the number one and number two, the questions.
Right over here.
Yeah, the two questions. One of them you multiplied, and the first one you Yeah, that's it.
Yeah,
That was the difference.
Yeah, so remember, you're letting the problem guide you. That's what we want to do. We want to let the problem guide you. So what I mean by that is you want to first analyze what is going on, and then you do the opposite. So over here, you see that right now we see that we're dividing by 3. So I want to do the opposite and multiply by 3. You see that there? Yes or no?
Yeah.
Cool. And so then from there, look at this one. Originally, we had multiplication. We see -8 times r. So we see multiplication. We're going to do the opposite and divide. So really solving equations and solving inequalities is about observing what's there and then perform the opposite operation. Is that making a little more sense there?
Yeah. The other one was positive, so okay.
Yeah. And so here, so it's not ever about positives or negatives. It's about the operation. That's what it's about. That's what it's about. So here we would flip the symbol because we divided by a negative. So that's why that flipped. It's only the negative right there that caused us to flip it. If you look over here, there is no negative. And so the symbol stays the same. And one more time over here, P divided by 3. There is no negative that we're dividing or multiplying by. And so therefore, the symbol stays the same. So just to recap, 2 things. 1, you will always play off of the operations that you see and do the opposite. And 2, when you're multiplying and dividing, either one by a negative, that's when you flip. That's when you flip.
Thank you.
No worries, man. And with more practice, again, with more practice that we have coming up, we'll definitely see it happening. So let me go ahead and get into this one over here. So we're going to skip over to 21 here. We're going to skip over to 21. And so let's check this out now. So 21, and let me actually go ahead and, oops. Did I change the color here? I definitely did. Let me white. And then, boom. Okay. So we're not going to need these right now. I was debating it again, but not going to be necessary for today. So with that said, I'm going to clear that out right there. Perfect. So let's just go ahead and check this out here. So we have 15 plus n is greater than 0. So 15 plus n is greater than 0. Sorry, Joe, I'll come back at the end for that one. So here, 15 plus n is greater than 0. Everybody, true or false? The goal is to get n by itself. True or false? Right. That's true. That is the goal, right? That is the goal. And everybody, is it also true? I'm acting like a lawyer here. Is it also true that 1 plus 2 is the same as 2 plus 1? Is it also true? Were you there that night? Were you there that evening? All right, Clark, I think we got him. All right, so yeah, 1 plus 2 is the same as 2 plus 1, right? It is the same. So everybody, for the sake of keeping things simple, to be able to see it clear in our heads, and of course, later on, we'll take shortcuts, but for the sake of seeing it a little more clear, is it safe to say that 15 plus n is the same as n plus 15? Is it safe to say that? Yes, absolutely is. And the reason that I do this is because a lot of the times when we see that 15 plus n or 2 plus x, has anybody here ever gotten confused on what to do to both sides when the number comes first before the letter? Right? That happens, right? That can definitely happen. And so just want to make sure that you know that really what this is right here, really what this is a plus 15. That you are basically saying, hey, look, if there were nothing there and you threw a 15 in there, you added the 15 in there. Like that's the operation that happened. The operation that's happening is you're adding a 15. So everybody, hook a guy up. What is the opposite of adding 15? Help me out here. Be specific. That's right. We are going to subtract 15 from both sides. That's exactly it right there, my party people. That's what's up. We are going to be subtracting 15 on both sides. Now, everybody, let's see who's been paying attention. The answer here, when we cancel out the 15s, it'll be n symbol. Does it change or stay the same? Who's been paying attention? Is the symbol gonna flip? or is it going to stay? All right, so you'll see a lot of people saying stay. And for those of us that are sitting in the back, like, wait, hold up. I see a negative. Why is it not changing, Mr. Anderson? Oops, my bad, coach. What is it? And the reason is because, remember, the rule is only if you are multiplying or dividing by a negative number. Adding or subtracting doesn't count. Doesn't count. Exactly. We're not multiplying or dividing, so it will stay the same, and you'll get negative 15. Exactly. I love the explanations by part of people. I love the explanations. Yes, only for multiplication and division. So I'll keep that there for 21. I'm going to move forward here to 23, and I'm going to go back to the other corner up here to get the 22 and 24. So everyone, if we take a look at x plus 6 is less than or equal to negative 13. Everyone, what do we do to both sides to kick this in the face one easy time? What do we do? What are we going to do? Yeah, that's right. We're going to be subtracting 6 on both sides. That is absolutely correct. Absolutely correct. So here we will subtract 6. Booyah. That's going to cancel, leaving us with x less than or equal to, because again, although we are dealing with a negative on both sides, it is by subtraction. It's not multiplication or division. It is simply subtraction. And so if we are negative 13 and then we subtract 6, everybody, what's going to happen there? If we subtract 13 and subtract 6, we are in total subtracting 19. It's like saying with money, if I spent $13, then I spent $6 more, I spent a total of 19. So long story short, again, if you're having a hard time dealing with negatives, again, I do have a video out on YouTube and plenty more in the program. But remember, if you're already negative and you're subtracting more, stay negative. Just add the numbers, keep it negative. 13 plus 6 is 19. Keep it negative. So the answer here, negative 19. So x is less than or equal to negative 19. And so with that said, let me zoom out just a little more here. And we're going to get ourselves going over here with a 22. So this is where things might get a little trickier. And this is exactly why I wanted to do 21 and 23 first, so we can take a look at 22 and 24. And I mean, still be able to get this, done confidently. So let's go ahead and take a look at 22, my party people. So let's take a look at 22 right there at the top. So with 22, everybody, hey, Christine, let's go. This is the part of class where we start figuring stuff out. So negative 8 minus k, again, everybody, my attention's right here, 22. Negative 8 minus k is greater than 7, So everybody, the goal is to get k by itself, right? And I'm looking at it. There's that negative 8 just sitting there menacingly. Everybody, that negative 8, you can treat that as a minus 8. You are subtracting 8. What is the opposite of subtracting 8, party people? That's right. The opposite of subtraction is addition. You can treat that as a negative 8, or you can treat that as minus 8. Either way works. Either way works. The opposite will be adding 8. And so with that said, boom. And we're going to have, does the negative on the k stay there, or does the negative disappear on the k? Does the negative stay or go away? Right, it stays, because we actually didn't do anything. We didn't do anything to the negative on the k. We took away the negative 8, but we did not do anything with the negative on the k. So it stays. And so we have negative k is greater than, everybody, 7 plus 8 gives me what? 15. So we have negative k is greater than 15. This is where we're sitting here like, okay, we're almost home free. I got to get k by itself. Everybody, what do I do? Divide by -1 on both sides. Exactly. Because remember, everybody, there is indeed a 1 in front of the k. If you want to imagine it there it is in red. I'll help you out. So we have the -1 in front of the k. To get rid of that negative on the k, we will divide by -1 on both sides. Everybody, what do I have to be on full alert for right now? What do I have to make sure I do? Hey, Christine, quick question. You feeling pretty good right now? Yeah, we'll flip the inequality. That's right. That's right, Marquette. So Marquette, so we don't flip it as -8 or -k minus 8, basically the same as number 21. Oh, no, Marquette, we can absolutely do this. So Marquette, I'm going to come back at the end and do that for you. I got you. Thank you for making sure I clarify. Thank you for making sure I clarify. But to finish this off, and I'm going to come back for you, Marquette. I got you. Thank you. Here we have, again, the dividing by negative on both sides. That's going to cancel us out right there, leaving us with k. But because we are dividing by a negative, this thing right here is going to get flipped. So instead of greater than, we will have less than. 15 divided by a -1 is -15. Right there. And so that's what the answer is going to be. Now, Marquette, I got you. So Marquette had a question. And I'm going to ask to see if anybody else here had the same question. Marquette was asking, hey, how come we didn't treat this the same way as we did 21? 21, you saw how we had 15 plus n and we changed it to n plus 15. Are we allowed to do that here? Are we allowed to start this off and say, hey, -k minus 8 is greater than 7? Can we do that? Can we do that? Yes, we can. So Marquette, you absolutely can. Marquette, follow along. I'm going to show you how this is no different. Watch this. So notice how, even if we have this going on, my first step can be adding 8 to both sides. And notice how it doesn't change the problem. We did the same thing here. The 8 cancels, and we add 7 and 8. Marquette, yes or no? Do you see that? Let me know. Cool. And so because of that, then the last step, notice how the last step is the exact same. Divide by -1. Divide by -1. And so from there, booyah, k, flip the sign, is less than -15. So does that make you feel any better, Marquette? Let me know. Let me know, because I did want to make sure that I touched on that because I didn't want to leave you confused there. But number 24 here. Sounds good, Karina. Thanks for that. So number 24 here. 6 minus x is greater than 25. So in this case here, everybody, is that 6 right now being added or subtracted? What's going on currently with that 6? Is it being added or subtracted? Right, it's currently, sorry, Joe, currently being added. And so we're going to need to do the opposite to get rid of it by subtracting it. So just to make sure that everybody's clear here, and I'm going to leave 22 up there too, just in case anybody's copying it still. But this, you can view this problem as this. Come on, arrow work. You always do. There we go. So we can treat that as this. Negative x plus 6 is greater than 25. You can treat it either way. Whichever way helps you see the operations is the way that I'm going to promote, okay? So let's take a look at it both ways. They're both going to work. Watch. So here, this is a positive 6. So the opposite thing to do would be subtract 6, but on both sides. Over here, what do you notice? Yeah, subtract 6 on both sides. In either case, it's going to cancel on the left. And on the right side, everybody, 25 minus 6 gives me a what? What's it going to give me? 19. That's right. 19, 19, 19. 25 minus 6 is 19. So with that said, we'll have negative x greater than 19. Negative x still greater than 19. Notice right there. My big old head's not in the way of that. It's the same thing. And so because of that, our last step, everybody, will be what? Right. It's going to be dividing by that -1 on both sides. So I'm going to go and zoom in now. So it's going to be dividing by that -1 on both sides. And so when you do that, you're going to have x, then you're going to swap the symbol, or flip the symbol, excuse me, flip the symbol, and you'll have a -19. So remember the shortcut, everybody. The shortcut that I taught y'all was, hey, look, if you want to get rid of a negative on the x or the y or the n or whatever, literally change everything sign, flip the symbol. Remember what I said earlier? Change the signs, flip the symbol. That's what it is. Watch this. Change the signs, positive x, -19, and flip the symbol. That's what I was saying earlier. That's what I was saying earlier. If you want to get rid of a negative, just change all the signs and flip the symbol. That's it. So is anybody starting, Karina, nice. Is anybody else starting to see that shortcut that I was talking about earlier? When I say, hey, look, just change the signs, flip the symbol. That's all you got to worry about there. That's really it. That is really it. Hey, no worries, Maya. Again, here. So if you follow I mean, these are both the same problem, obviously. But what we did at the end here was just divide by a -1. That's all it was. And remember, whenever you multiply or divide by a negative, you flip the symbol. So that greater than turns into a less than. And then here, boom, boom. Yeah, it just takes practice, guys, for sure. It definitely takes some practice. Definitely. Exactly, Lizzie. Exactly. Exactly. So 26 here. We have x plus 17 is greater than 23. Everyone, is this an easy one or a hard one to you personally? What's your opinion on this one? Oh, okay. Oh, it's all easy now, huh? Oh, weren't y'all saying inequalities were the devil in the beginning of this? Weren't y'all talking about going to church and praying to God that this would go away on the ASVAB? Now y'all looking at this like, oh, Leonardo DiCaprio. Okay, I see y'all. Okay, what are we gonna do to both sides, everybody? Man, y'all acting brand new today. What are we doing here? Yeah, easy, Nico. Right on. Yep, we're gonna subtract 17 on both sides. Subtract 17 on both sides, and booyah, bread and butter right there. That's gonna cancel. We're not gonna flip the symbol because we're not dividing or multiplying by a negative. And so because of that, x is greater than 6. We want, y'all want the smoke? All right, sounds good. So that was it right there. What I'm going to do now is we're going to present ourselves with another set of problems. Now, again, I'm going to give you, let me see how many there are. 6. Okay. So I'm going to give you 6 problems here on this next sheet. And then I'm going to try to do one problem where it's multi-step, where you have multiplication and addition or subtraction in there. So I want to try to get it. I'm going to try to squeeze one of those in there. But I'm going to be honest with you. If I can't squeeze those harder ones in there, again, as I promised, I'm going to be filming all of the other problems that I don't get to. For your reference, this is what I'm going to be filming. And this is why I'm asking you to give me till like Wednesday, probably Thursday for this. After I'm done with the practice test tomorrow, I'm going to need to breathe because I've been working on this project forever. But these are all of the problems I'm going to be filming for you. 2, 6, 10, or 12. All of these, all of these, all of these, all of these, all of them. I'm filming all 40 of these. I'm going to try to and get them to you, okay? So with that said, I want y'all to try these out, and then we're going to, go over them. Oh, we got to do 25, actually. Yeah, let's do this one. We'll do 25. I'll give you the opportunity to do the next page, and we'll wrap things up. Here we go. So x plus -18 is greater than -12. Everybody write that one down because this is a unique looking problem. It ain't crap. It's nothing. Trust me, it's nothing. I got you. So you're looking at this when you're saying, okay, x plus -18. Everybody, adding a negative, isn't that the same thing as just subtracting? Like, isn't that just the same thing as just saying, hey, x minus 18? Aren't those the same thing? Aren't those the same thing? Yeah, they are. So yeah, those are the exact same thing. You're good. You don't have much to worry about. You don't have much to worry about. And so with that, We're going to add 18 on both sides. And that's it. That's really it. With this one, that's the fun in it. Super easy. It's not going to be 30, though. Not going to be 30 because you have a negative 12 and a positive 18. So if you have a negative 12 plus 18, you can think about that as 18 minus 12. Because remember, 1 plus 2 is the same as 2 plus 1. So if you're going to rearrange it, just bring the symbol or the sign, excuse me, bring the sign with it. So we have a negative 12 plus 18. 18 minus 12. Everybody, 18 minus 12 is what? 6, correct. And so we have x is greater than 6. That's what the answer would be there. So with that said, again, the negative numbers, let me go ahead and actually just pull this up right now, or actually while y'all practice. So I'm going to give you all the practice right now, and I'm also going to post in the chat here, I'm going to post a link to the lesson that I did on negative numbers. That way, anybody who's here who is struggling with negative numbers, I don't care if you're in my program or not, I want to share this video with you because you deserve to benefit from it. Okay, so here's the set, 6 problems. Let me go ahead and blank out those graphs there so you don't have to worry about them. I absolutely regret building these graphs here. Was not even necessary. But there you go. I'm going to give us a whole here 3 minutes. So here we go. Number 27. Only step that we're going to do is going to be add 7 to both sides. Add 7 to both sides. That's going to give you n greater than negative 7 right there. So 27 is n is greater than negative 7. So then 28, negative 11 minus x is greater than negative 10. So one quick thing here, everybody. I'm looking at this one and I automatically know that I'm gonna be flipping the symbol. Why? Because there's a negative on the x. Because if there's ever a negative on the variable you're trying to find, that means you're gonna have to divide that negative out or multiply it out depending on what it looks like. But if there is a negative with the variable you're solving for, you're gonna be flipping the symbol. And you can use that to look forward and kind of like give yourself that foresight to predict what's gonna happen. So does that make sense to anybody? Because there's a negative on the x, we will be flipping the symbol. Who sees that? Cool, here, sounds good. So let's go ahead and get it here. So what we have is adding 11 at first to just get that out of the way. Once we do that, goodbye. Negative x greater than, so we have negative 10 plus 11, positive 1. Because you see that 10 and 11 are one number away from each other, but the 11 is the positive 1, the 10 is the negative 1, so you're left with a positive 1. So here, you can do one of two things. You can divide by the negative 1 on both sides, or you can just change everything's sign, flip the symbol, do the same thing, same exact thing. And so the answer will be, after you divide by that negative 1, you're going to have change signs, flip the symbol. X is less than negative 1. All right, boom. So with that, we're going to go ahead and head ourselves into 29. Zoom user, when I let you talk, tell me your name because I hate calling you Zoom user, and then ask your question.
Tura.
Tura?
Yeah. So if it's not, if the number is it's not about the number, if it's negative, if the variable is negative, we flip and we divide.
Yeah.
That was the key. That was the key. So,
yeah, exactly. There's a negative in front of the variable. Absolutely, that's correct.
Okay. Thank you.
Yeah, no worries, man. All good. All right, so let's go ahead and zoom on this one here. So here what we're going to do is we are going to be subtracting 19 on both sides here. Once we subtract 19, we're going to have that cancel out. N is less than negative 7. I'm going to be doing rapid fire here because it's already 8:01, so allow me to finish up. So that way those can sign up if they'd like to. So here, n minus 6 is greater than 1, adding 6 on both sides. Bye-bye. N is greater than 7. Booyah, that's right, London. Next, 31. We have, variable on the right side. Crap, right? Look, honestly, there's two ways you can do this. One, you can just flip everything now or swap everything now, or you can do it at the end. either way is fine. If you want to do it in the beginning, it's probably going to be a little easier for you. But again, it really doesn't matter. So I'm going to go ahead and just swap these out. I'm going to swap these out. And so I'm just going to write -8 minus x. And this has to flip less than or equal to -6. So that's what that is here. If you want to swap it out, just flip the symbol. There it is. So here we will go ahead and add 8, booyah. And from here, we have -x less than or equal to +2. But we have a negative in front of the x. So we're going to go ahead and solve and flip the symbol again. So with that, we're going to have x greater than or equal to -2. There's that. And then lastly, we have -4 is greater than -20 plus m. In this problem, I'm going to keep everything on the right side. Then I'll flip at the end. Watch this. So here, I'm going to add 20, because again, you are subtracting 20 here. So I'm going to add 20 on both sides. Booyah, goodbye. And we're going to have ourselves m, keep the greater, and then here we're going to have 16. But again, typically we want that variable on the left side. So what we're going to do is we will go ahead and swap. And remember, if we swap, we will go ahead and have to yeet that symbol, flip it over, we're good. So we're going to end up having m is less than 16. Because again, if you look at it, this is saying, hey, 16 is bigger than m. 16 is pointing at m saying, ha, I'm bigger than you. And it's still doing the same thing. Still doing the same thing. And so with that said, my party people, how did we do? Did we get all of them correct? Did we miss one, miss two, miss three? How are we feeling, guys? How are we feeling? Get them all correct. Missed one, missed two. Hey, look, again, it doesn't matter if you missed one or two. The question is, do you understand why? That's the bigger question. So let me know if you understand why, for sure. But like I said, my party people, at the end of the day, it's all about the why. And once you know what needs to be done, make the sacrifice, take the time to practice, because if you don't put in the time to practice now, you're going to have to put in the time for the retake later. So put in the time to practice now, so that way you don't have to spend it later, man. I'm telling you right now, you got to start early and often and get it done. Sarjo, here you go. Take a screenshot real quick of number 8. And then we are going to wrap things up and allow those who are interested in the All Access Pass to go ahead and sign up. So here's number 8, Sarjo. Go ahead right there. Let's take a screenshot. Going to go ahead and give you a copy down. 5, 4, 3, 2, and boom. All right. So with that said, everybody, on a scale of 1 to 10, how was this session for you? Oh, yeah, and by the way, so the 40 questions, oh, by the way, my all access party people. So the 40 questions that you just saw, those were the basics. I'm also going to be filming these. You see these? You guys want to know how to do these? Yes or no? Do y'all want to know how to do these? So these are also the ones I'm going to be filming and putting in the course as well. These are the ones. These are the ones. These are the ones. And also multi-step, where you have a lot of crap going on both sides. I'm going to be filming all of these, all right? I'm going to be filming all of these, all those, all those.